Hello everyone, we are Team MedSpark. Today we are addressing a profound challenge in traditional healthcare, a challenge hidden in plain sight, the reliance on subjective human taste or rasa for identifying Dravya Ayurvedic substances. The system is inconsistent and highly vulnerable to adulteration. The global herbal medicine market is projected to reach over $430 billion by 2028, yet up to 20 to 40% of marketed herbal samples are reported as adulterated or mislabeled. This causes massive export rejections and erodes global trust. We realize that for traditional knowledge to thrive in the modern world, it needs a scientific, objective, and scalable validation system. That's when we MedSpa came up with an idea, the AI powered e-tongue for Ayurvedic herb authentication. Our solution is a low cost hardware based e-tongue that uses a multi sensor array and advanced machine learning to mimic human taste buds. The system provides real time objective quality testing of herbal extracts, ensuring authenticity and standardization. Our core mission is to bridge the subjective rasa framework with objective data driven validation, creating a standardized digital taste map of herbs. Our process is comprehensive, delivering a reproducible result every time. Here's the hardware flow and the software flow of our project. Let's understand about that. First, let me explain about the hardware flow. Starting with the sample preparation, the sample is placed in the 3D printed chamber for consistency. Later on, multi-sensor array. This array will be consisting of different sensors sensing our required parameters. Here we'll be having a different sensors such as pH, TDS, ORP, turbidity, temperature, voltammetry and RF resonator. The pH sensor is for checking pH, that is acidity or alkalinity. The TDS is for ionic concentrations. The ORP detects the redox potential. Turbidity, it detects the cloudiness or the opacity. The temperature is for checking the temperature of the sample. The voltammetry measures the electrochemical response. Each generates digital signals. The RF resonator captures the dielectric taste fingerprints. The signals are sent to the Raspberry Pi for processing. The extracted features stored as the digital fingerprints. These fingerprints are sent to the AI/ML decision layer. Here, the model compares new sample with reference data and it generates outputs such as herb identification, the purity percentage, and the adulteration alert, that is pass or fail. This data is uploaded to the cloud. Let's understand about the software flow. In the front end, the user can see the real-time analysis, the purity percentage, the adulteration status. Next, in the back end, it handles the API request, authentication, and real-time updates. Here, the PostgreSQL plus MongoDB databases manages the structured and documented data. Next, the cloud stores the herbal fingerprints for comparison and training. The machine learning layer is capable of detecting herb type, origin, and adulteration. These models are retrained for regional herbs or new formulation. You can see a document link over there. Click that. Once you click the document link, it will direct you to a documentation. It consists of all the documentation we have made for our project. It also consists of all the researches we have done. It consists every detail about our project. Once you go through that, you'll get to know about our project very well. Do check this out. Let me take you on a journey that starts not in a lab but at a farm in India, where a simple leaf holds incredible medicinal promise. But how do you hear that story? How do you know if the promise is real or if the leaf has been tainted by sophisticated fraud? This is the core problem we set out to solve. For centuries, we relied on subjective human taste, the rasa framework, to authenticate these herbs. But in today's global market, that method is failing, enabling an estimated 40% of adulteration rate. Once you click this link here, you will land on a Herb Tongue AI homepage and you instantly get the promise. You see a calm, powerful visual. The tagline is crisp, digital taste analysis for herbal intelligence. There is no ambiguity. So, first you have to click this try live demo, and you'll be having three different credentials. You can type this to login. If not, just click this demo login and just sign in. Okay. As you scroll, the website immediately immerses you in the pain points, the opaque quality checks, failed exports, and the clash between ancient wisdom and modern science. This is the urgency. We needed a sensor that could speak in the language of rasa but write its finding in the language of code. You can see here the sample that I tested today, the authenticity rate so far, and the average purity. So the main part of the site is this live analysis. Here you can see several samples that are tested. Here there are the authentic samples and also the adulterated samples. So first you have to select any of the samples. Scroll down. You can see here analyze sample. Click that. It generates the analysis. Now you can see here the adulteration alert is pass. That is, it is safe to use. You can also have a recommendation here. It is good quality and it is safe for use. And it also says the taste of the profile. It is bitter and it's pungent. And here, see, this is the main thing. Let me tell you the importance of these fingerprints. We already have predefined trained samples in our cloud. Once after our new sample generates its fingerprints, this new fingerprints is compared with already stored samples. It checks how near our sample is to the predefined sample and checks if it has exceeded the level or not. It will then say if the output is safe to use or not, that is adulterated or authenticated. This is how we get the output of each sample. You are conducting this experiment on an unknown sample. Even that unknown sample has to pass all the sensors and it generates a fingerprint. Now that newly generated fingerprint is compared with the stored fingerprints. If any of the fingerprint is matched, we can say that this unknown sample has particular known characteristics and the user can know about that unknown sample well. Here you can see the sensor overview. It has the outputs of every sensor and it also has the required readings. It compared these required readings with the obtained readings and it generates the output such as herb identification, the percentage of the purity and the adulteration alert. You can also see the voltage and current of the sample. This is how you can check the analysis of the sample, adulterated sample. See, the adulteration alert is fail. It is saying likely salt but adulteration reject batch. It is saying that you have this is not safe for use and it is salty and bitter. Same. It is also generates the radar fingerprint, the sensor overview, the current versus voltage graphs, everything. Now let me tell you about this another icon that is test history. It consists of all the samples we have tested before. Here you can also find any sample by just entering the date. Once you enter the date on which day you have tested the sample, it gives you the data of that sample. These are all the samples that we have tested before. So if you want to upload any file that you have tested, you have to convert the file in this format and next click on choose file and just choose the file and upload it. Once you are done with it, sign out. The system is designed for feasibility and viability. It has scalable hardware design. The modular sensor array allows new sensor to be plugged in for new components, scaling from low-cost handhelds to advanced lab systems. It satisfies multi-industry applicability. Our platform can be tuned not just for Ayurveda but also pharma, food and beverages, water quality and herbal exports. It has customizable AI models. The ML algorithms can be retrained for region-specific herbs or formulations with continuous accuracy improvement. The impact of the e-tongue is transformative. We remove the subjectivity of human taste, leading to fast, reliable herbal analysis. We prevent fake herbs and synthetic adulterants that mimic taste but lack efficacy from entering the market. By offering AI backed certification and a universally recognized herbal fingerprint library, we increase trust in herbal exports, reducing fraud and boosting India's international credibility. This is a direct answer to the challenge of export rejections. Our AI models can classify herbs not just by taste but by geographic origin, storage condition, and adulteration type, linking rasa to pharmacological potency. This innovation creates a standardized digital pharmacopoeia accepted by both traditional and modern systems. It's about preserving heritage while making it globally acceptable. We are uniquely fusing Ayurvedic principles with cutting edge RF and multi sensor technology and AI. Unlike costly lab tests or bulky prototypes, our solution is portable, affordable, and regulator ready. Backed by a passionate, skilled team, we are setting a new standard in herbal quality assessment. The e-tongue is not just a project, it's the future of quality control, ensuring safer, standardized herbal products for consumers worldwide. We are ready to take this scalable, industry grade innovation into the market. Thank you.